Here's my second video with trig with chain rule. As you can see, I've named it part 2. Okay, so these are very tricky problems, and no, I don't mean like we are trying to purposely make awful problems. What I'm saying is that the chain rule is so small that students don't even see it. So here's an example. F of x equals sine squared x. People are like, this is chain rule? Isn't the derivative of sine just cosine? So it'd be cosine squared x? No, unfortunately it's not. And it's because of this notation of sine squared x actually is sine of x squared. That's what that means. In trigonometry, we write this way. It's kind of the normal notation. But for chain rule purposes, it's actually better to see it this way. So what I want to remind you guys is that every time you see this, it's technically this. So you can write it or think it, but you need to definitely be imagining it, okay? So now when I take the derivative of this, we can see an outside and an inside. The outside is the exponent, the inside's the sign. So I'm going to take the derivative of the exponent, leave the inside alone, and then times it by the derivative of the inside. And the derivative of sine is cosine. So here, the derivative of sine squared x is actually 2 sine x cosine x, or 2 cosine x sine x. Either way, but that's what it is. Okay, let's try another one. What if I had g of x equals cosine to the 5th x? All right, well, we just talked about how this is shorthand notation for cosine x to the 5th. So I've got my inside and my outside. Okay, so if I take the derivative of the outside, but leave the inside alone, and then times it by the derivative of the inside. Now, super important. Sometimes students space out during the problem and they think this means subtraction. Yeah, no, this is multiplying by a negative sine x. Okay, so I'm going to throw that to the front. We're going to call this negative 5 sine x cosine x to the 4th, or if you want to switch back to trig notation, you could do it either way. There's our derivative. Okay. I'm going to do one more that's actually pretty tricky. It doesn't look that bad, but once you get into it, you go, oh my goodness, hold on. All right, my last one here is y equals secant squared 4x. And again, this is not a product. This is actually chain rule, and this is a double chain rule, okay? So what I have is, this is the secant of 4x. And then it's all squared. That's what that means. Okay, so I have a double chain rule. One outside function is the 2, and this is my inside. And then here I have the outside and an inside. So let's try it. Okay, so taking the derivative of the power of 2, I'm going to get 2 secant 4x all to the first. So I take the derivative of the outside, leave the inside alone. And now I want to take the derivative of secant 4x. All right, well, the derivative of secant is secant x tan x. Secant x tan x, but my inside is 4x, so that's what goes here. Tricky, right? Okay, so this is the inside that I'm leaving alone. All right, but I still have to take the derivative of 4x, so the derivative of 4x is 4. Now you only have to take the derivative of 4x once because the inside's only once. So the derivative of 4x is just that 1 4. Whew. All right, so let's smush it together. A 4 and a 2 is 8. I've got one secant and another secant. That's 2 of them. And then I've got a tan 4x. So secant squared 4x tan 4x. That's the derivative. Told you it was going to be tricky. All right, keep working at it, keep practicing, and make sure you know all your rules in 3-3, 3-4, 3-5, 3-6 before you even attempt chain rule, or it's going to go down in a ball of flames. All right, good luck.